Well, my name is Craig Gallen, and like Netflix, I'm also a partner of the OpenNMS group. I support accounts in the UK and Ireland mostly, and jump into a few other things now and again as well. And I also, as I've sort of indicated in my charts, have another day job. I'm an associate lecturer at Solent University in Southampton. So I kind of throw OpenNMS into the course quite a lot, and kind of mix and match the two. So that's great. So I'm going to be talking about IoT, or fog computing, as has been alluded to earlier on, and OpenNMS. And in this talk, I wanted to just start off with a sort of general discussion of IoT. When I kind of got into this, it was all new to me. So I'm suspecting that for a lot of you, maybe you've heard of IoT, but you don't know an awful lot about it. You probably know even less after my talk than you knew when you started, because I'll confuse you and give you all sorts of wrong information. But hopefully it'll be something of interest. Then I'm going to look specifically at MQTT, which is a protocol that has been adopted by the IoT community. In my opinion, it doesn't do an awful lot different to SNMP, but well, never mind about that. But it is the protocol of choice for IoT devices. Then I'm going to talk about work that I've been doing on the OpenNMS IoT plugin, which is a bit of software that enables OpenNMS to talk MQTT to MQTT brokers and thus pick up data from devices. And then I've got a number of use cases because I've been trying this out with various people around the world. And so it's still very much work in progress. It works. But I need more people to try it out and give me feedback and see if we can take this forwards. What I'll just say about plugins is that, as some of you know, in a sort of previous talk at OUCE, I talked about the OpenNMS plugin manager, which is something that I kind of went about creating some time ago. And it exists in all versions of OpenNMS now. And it's basically a way for people to write code independently of the main OpenNMS development stream and drop their code into OpenNMS and have it show up like a plugin. And the real motivation for that was to try and encourage a wider community of developers to get involved in OpenNMS, researchers, folks like that, who wanted to take OpenNMS as a platform and add software onto it. But we weren't yet in a position to take that software, whatever form it was in, into the main OpenNMS code base. So you kind of use this stuff at your own risk, but it doesn't actually damage anything in the core OpenNMS code base when you use it. So that's kind of the way it's been positioned. Now, some plugins do actually exist in OpenNMS, and they are basically, they started off life in this way as a sort of separate thing outside of OpenNMS, and then they were pulled into OpenNMS as part of the main code base. So that could be the way some of this goes, but it may not. So I just really wanted to say, it's works with OpenNMS, but it is independently developed as a plugin for OpenNMS, and I think it's quite a good example of that model. So let me start with a bit of a little conversation about the Internet of Things. So the best and simplest definition I've come across of the Internet of Things is simply the point of time when more things or objects were connected to the Internet than people. In other words, the Internet grew up basically as a technology for people to browse the Internet and get information. But the Internet of Things is about computers talking through the Internet to other computers for whatever purpose. When we talk about fog computing, we're obviously, as Uwe alluded to, we're talking about moving intelligence to the edge. And what we're finding is that there's incredibly intelligent but very, very small devices that can now sit on the edge of your compute environment that will chatter away to each other and will also talk back to some sort of cloud environment. And they operate autonomously and independently. And they can be as simple as a chip put into your baked bean can that allows it to talk to the point of sale as you walk out of the shop, or it can be remote sensors, car parking monitors, health monitors, all sorts of things it could be that are things that talk through the internet. Now, the other thing to say about it is, in a lot of ways, this is nothing new. A lot of what the Internet of Things is being used for actually has been done using traditional SCADA systems for years and years and years. And a lot of protocols and technologies have grown up over the years for industrial control and all the rest. The difference with the Internet of Things is that instead of using proprietary or gatewayed protocols for these things talking to each other, now we're just using IP. So these devices can, in theory, talk to any other IP device that they can get access to. And that brings its own challenges, obviously, in terms of security. Distributed denial of service attacks and all that sort of thing are possible because of all of these little devices that are out there that could be controlled by agents who are bad people. But in reality, it also brings the possibility for new services and new applications to be developed that couldn't otherwise have been developed. Now you can see the growth here, and basically we're reaching the point where by 2020 Cisco says that there'll be 50 billion devices of some sort that represent the Internet of Things. Who knows where they get that figure from, but this is the sort of growth that we're projecting, that we're seeing. So clearly everybody is thinking, well, where there's growth, there's money. And there's an opportunity here of some sort. And so I've been trying to work out, well, what, if any, is the opportunity for OpenNMS or for OpenNMS users within this IoT space. Now, I'm involved in the Telemanagement Forum, which is an organization that originally sort of grew up with telcos, but now has actually got many members that are sort of large providers of sort of cloud services and the like. So, you know, Facebook, Google, whoever, they are also members now of the TM Forum. And the TM Forum has been basically moving from just looking at telco problems to looking at problems of digital services and how do you deliver digital services of all different types. So one of their programs is looking at smart cities and trying to come up with a common framework for a smart city. Other programs are looking at smart e-health. And this program that I've been sort of looking at is the Internet of Everything program, which is really, okay, well, what does this Internet of Things thing mean for people that are trying to create value out of it? And they came up with this model, which you can see here, which basically says that within the ecosystem, there are a number of layers that you need to be concerned about. And you can see that obviously at the data layer, you've got all of these little devices, of which there's going to be millions, all talking away to something. Then you've got a connectivity layer. So the people, you know, folk like Vodafone and other big mobile providers are looking at the connectivity there because they're saying that 5G, LTE and beyond is going to be about dealing with these millions and millions of these devices, and they have to completely re-engineer their network to be able to handle not the volume of traffic, because the volume from these devices is actually quite small. It's just the number of devices, and how do you handle them securely? How do you register them? How do you get them online? And then talking back to whatever application they're supposed to be talking to and not to something else. So that sort of layer of connectivity is really where, you know, large service providers are looking, and wireless providers in particular are looking at, okay, what do we do to do this? Then enablement is where the cloud service providers, mostly folks like IBM, Google, Amazon, are saying, well, that's great, we've got a way of connecting to these devices, but what do we do with the data when it arrives? So they're saying, well, it's a big data problem, so we'll provide a big data store of some sort. And then we've got all this data, we need to do something with it, so we'll provide some analytics function of some sort. So IBM, for instance, say, well, if you use Watson to analyze your data coming in, you can do all sorts of artificial intelligence against the data. So they're saying it's a big data problem, yes, but it's more than a big data problem. It's a problem of taking the information you've got and turning it into something useful for whatever the application space is. And in order to do that, you need certain components that are going to be common across all of these IoT applications. And they're saying, well, we can provide those components at scale and at low cost, they would say. Okay, so that's where that layer is. So, you know, you can go to Amazon IoT, for instance, and see all the different things that they provide in terms of data management and all the rest for the data that's being pulled up from the underlying network. And then you've got the application providers. And what they're saying is, well, you know, there's going to be many, many different applications for this. So in the health sector, it'll be about predicting if somebody's going to have a heart attack and watching some old people in their homes and whatever else to actually provide a service that will help people with their health needs. And you'd see the same thing with transport. So we're going to have all of these cars that are going to be autonomous, driving around. They will need to be managed as a thing as well. So that's another sector that's important. And you can see, I mean, I'm going to talk to all of them, but you get the idea that there's a vertical which says these are our applications which are going to use this underlying technology. But then there's a horizontal that says all of these applications use the same technology underneath, and so the big players are lining up to provide that technology. Now, the way this is being positioned, and the way I've seen it being positioned in hackathons and things like that, is that it's really, really easy to wire up these applications to deliver some sort of end user application. And that's the way they're positioning it. And they're saying to, you know, end users, well, you know, we've provided this big heavyweight technology, you just need to wire it up and provide a UI, and you'll have a wonderful application that you can make millions of dollars out of. Well, that is the way it's being positioned, but I don't believe that's true. I actually think that delivering real applications is not just going to be a matter of wiring together stuff that exists in the sort of underlying layers. And you can do that for a prototype, and it'll be fine. But if you want to get it running at scale, or you want to get it running in a way that is the way you want it to run, not the way everybody else might want it to run, then you're going to have to do your own programming. And by the way, you also don't want to find yourself locked in to these enablement platforms. So if I said, I'm going to build all of my stuff on top of Amazon's IoT platform or on top of Google's IoT platform, I don't want to be in a position 5 years down the road where I'm saying, well, actually, I'd like to switch, but my application has been so tied in to whatever services these underlying guys are providing that it's actually impossible for me to switch. And of course, the problem here is as well, although they're saying, well, you know, it's actually very cheap, it's only fractions of a cent to send a message. When this thing scales up, suddenly these guys are making an awful lot of money out of whatever it is you're sending. And if you've got millions of devices out there over which you've got no control, which are autonomously sending messages everywhere, you could be charged a mint for what's going on, right? And I'm sure that that features in someone's business plan somewhere. Okay. So my point is that this is kind of the big picture of everything. And if you go on and you look at the IoT platform big players, so this is just taken from a survey. I don't know how accurate the data is, but basically the guys in the middle here sort of show up as folks like you know, Amazon IoT, Google IoT, and whatever, and then a number of smaller players that are sort of showing down in the weeds. But they're positioning themselves basically to the developer community as, you want to do IoT? Dead easy, use my platform, it all works. And for prototype development, brilliant. But if you want to move to production, you may be charged an arm and a leg, like I said. So we're up against these big players who are you know, out there and positioning their technology and trying to capture space and mind share in all of these potential application providers. Now, we also are seeing the emergence of IoT stacks, which are open source. So obviously, the open source guys want to get into the game. And these are just two examples. There are also stacks out there for smart city. So there's a group in Spain who are producing a smart city platform. And there's groups all over sort of producing stacks that are targeted at particular application areas. And that's great. You know, I'm glad people are doing this. But the problem is, in my experience, it's complex and difficult to deploy these single-purpose platforms. And by the way, they only do that which they were designed for. They can't do anything else. And they aren't really very mature. They've only been around for a relatively small space of time. So Eclipse Kapua is one example of a platform, and they offer all of these services. device registry, managing your devices, data management, and all the rest. And, very useful, but still very much a prototype kind of thing. And there may well be commercial support out there for it, but it's certainly not being used, as far as I'm aware, in production to a great extent. So this is kind of the space that OpenNMS is playing in, really, if it wants to get into IoT. Lots and lots of developers developing these stacks and coming up with this brand new stuff, but it's all very new, quite immature, and doesn't yet have a very large user base. Whereas OpenNMS, has been around forever in the scale of things, has a good user base, has a support community. Potentially, if it could play in this space, it could give people a much more robust platform on which to do their IoT stuff, and could play alongside these other stacks. There's no reason that it would replace everything. It can just be part of the mix, but it might give a much more sustainable solution in the short term than some of these guys are providing. So where would OpenNMS fit within IoT? Well, if you think about it, we really do fit in all of the layers. We have visualization capabilities with Grafana, but we also have our measurements API on top of NMS. So you can build any UI you want with any technology you like using the measurements API. So really, it does everything that these other platforms do in terms of exposing data, and some more besides, because it's got the calculations built into the API. You can withdraw data and run calculations on them as you pull the data out. So there's quite a lot there in terms of visualization that we can do out of the box. Then, if we've got a large amount of data to store, well, we've now got Cassandra as our back-end database, so we're really no longer limited in terms of how much data we want to store. And we also have connectivity to Elasticsearch. So again, if you want to push the data into Elasticsearch for your application, that's fine. We can do that as well. So in terms of the data storage and processing, we actually have an awful lot of what people might need within that space. What we don't do, obviously, and probably what we shouldn't do, is we don't do the actual brokers and connectivity technology for MQTT. But we can manage it. So, we could manage Mosquito, we could manage ActiveMQ, we can provide a capability for if somebody wants to build out their own IoT platform, we can manage those devices. And so Eclipse Cura is an example of something that's built on top of Carafe. Well, that's very similar to what we do with Minions. So again, there's a synergy there. There's a way in which we could work together with Eclipse Cura, or OpenHub is another one. OpenHub is a project for smart homes. And again, it's built on top of Carafe. So again, reasons to think we could work with them if we wanted to do that. So what I'm saying basically is that I think OpenNMS really does provide a lot of capability that could complement other solutions, or could work with, if you used a large broker that's providing, MQTT, like Amazon IoT provides just an MQTT broker, which is a relatively low-cost service. You could use that and then use OpenNMS to do all the data analytics and save yourself a BOM in the analytics. So there's ways in which we can mix and match. Now, the other two things that I'd want to say about it are, we're already doing IoT systems monitoring. So we've got cases where we're monitoring, in the UK, we're monitoring a large wireless IoT network, Census, which is being used for smart meter applications. And we're monitoring smart meter applications as well. So we're not collecting the data in that case, but we're monitoring the infrastructure. So we have good track record of being able to monitor the actual IoT platform itself, but we can also now do the IoT measurements. So we don't have to just monitor the platform, we could actually be the platform as well to pick up those measurements. And the other thing to say is, the likes of Google and Amazon and that, I'm sure will have their place, and their place will probably be in situations where you have very, very, very large data sets. Like we've got this 11 million electric gas meters in the UK are being monitored with MQTT. I mean, I don't think OpenNMS is going to do 11 million devices for quite a while yet. We're hoping to get there, but that's not a space we're going to play in, particularly at this point. But we don't need to, because there is going to be a long tail of applications with a relatively small number of sensors. And the thing that the whole IoT message gives us is that it's now possible to deploy sensors anywhere you want and have connectivity from the sensors back to your application. Choose me monitoring flood warnings, whatever it is in a particular region that could use OpenNMS as a platform to actually do the data analytics side of stuff and visualization and monitoring and alerting and reporting and everything like that that it does already. But they are able to do that because other people are providing the connectivity for MQTT and brokers and all that sort of stuff. And that will be done by the service providers of the likes of Amazon or whoever else. So there's an opportunity here in the long tail for many uses of OpenNMS. We could do the whole thing in some sense, but we can also do part of it and not have to worry about, is it big data? Well, it may be big for our application, but it doesn't have to be the millions and billions of data sets for it to be useful. So that was kind of a general discussion of IoT. So I wanted to move on now to talk about MQTT, which is the protocol of choice for IoT applications. Other protocols are available, as I said, but at the moment this seems to be the one that everybody's talking about. So MQTT has been around since 1999. It was invented by some guys out of IBM, basically. And it's intended to be something that uses a small code footprint. So the idea is it's not a heavyweight protocol. It'll run in a very small, lightweight device. And it doesn't have huge numbers of options. It just has ways of registering to receive messages or registering to send messages. And so you will always have an MQTT broker. And the IoT device acts as a client to the broker, and it registers, and it can then send events into the broker or messages into the broker. And then the applications are also clients of the broker that register to receive messages. And that's all there really is to it. You receive a message as a client, you can send a message as a client, and then the devices receive and send messages. And the broker really sits in the middle, just sending the messages to the right place. It's a publish subscribe messaging protocol. So whenever you sign up as a client, you tell the broker the messages you want to receive, and you give the broker a filter, which I'll come on to in a minute, that filter basically says, I want these types of message from this type of device, from this particular region, and the broker will then just send you those messages and won't send you anything else. And similarly, if you're an IoT device, you just send a message in that says, I am this device in this region, I'm sending you these messages, and you're registering to send the messages, or also registering to receive a message which could come from the client. Okay? So that's the key thing. And the application message is very simple. You have a topic, you have a QoS, and you have a payload, and nothing else in the message. So, as I said, the message basically contains the client ID, which basically identifies who you are, the topic that you're sending to or you want to receive from, the QoS, which I'll come on to in a second, and the payload. The payload is just a string of bytes. That's all it is. You can put, strings, you can put protobuf, you can put JSON, you can put XML in that string of bytes, whatever you want. But as far as MQTT is concerned, the payload is just a string of bytes. There's nothing else that it knows about that except its length. That's it. The topic, the QoS, I'll just say very briefly. So there's 3 levels of quality of service. QoS 0 is a bit like an SNMP trap, fire and forget. It may or may not arrive, but I don't need to worry about it anymore. So you just send the message and hopefully somebody will receive it. QoS 1 is at least one delivery, and there's a whole thing about how it actually works, but it basically means that it will guarantee that the message will arrive once, but it doesn't guarantee it you won't get more than one message. So it could duplicate the message. You might receive the message 3 or 4 times. That will be the same message, but it guarantees that it will at least arrive once. And then QoS 2 is exactly once delivery, where it guarantees that the message will be delivered once and only once to you. And obviously, this gets more and more complicated to implement. So the QoS2 requires, I believe it's 4 messages backwards and forwards between the client and the device to actually guarantee that delivery on time. QoS2 uses less, and QoS1 is just 1 message sent. So the bandwidth requirements for these 3 levels of QoS are different. And although it might not seem much, if you've got millions of these things, you may decide that QoS1 is all you're worried about. Just send and hope it arrives, because I don't want to have a whole stack of messages going backwards and forwards to these millions of devices. So then the topic. Well, if you remember, the idea of IoT is to basically identify the sensor that is sending me the data. And of course, you've got devices. It could be Raspberry Pi, it could be, Beetlebone, it could be any number of things that have got these sensors connected to them. And then you have a gateway, which is kind of, a sort of aggregator of everything. Now, this is just hypothetical. You can have a hierarchy as big as you like. It doesn't matter. The point is that in order to get a message from sensor C here, I need to say register to get messages from gateway 1, device 1, sensor C. Or I might say, well, I want to get messages from sensor A, gateway 1, sensor 2, sensor A. So whenever these devices send their message, they will identify themselves to the topic based on that kind of hierarchy. But on the other end, if you want to receive the message, you've got to put that hierarchy in when you want to receive it. Now, the key and clever thing is that you can apply a topic filter whenever you register to receive messages. So, for instance, this is a wildcard. So if I put in, I registered and said I wanted to receive GW2 hash, that would say, I want to receive every message that every device under GW2 could send me. And I don't want it to be filtered beyond that. I just want to receive every message from GW2 and all the devices below it. But I could say, I want to receive GW1 device 1. The plus here is just a wildcard for that particular part of the path. And that would say, I want to receive every message from device 1, but I don't care which sensor it comes from. So you can make up a selector basically using the path notation with either a wildcard hash or a wildcard just for a segment. And that way you can say, these messages from this device or from this region of this type should go to this particular application. And you're registering to say what types of messages from what particular region you're coming from. And you can be very sophisticated about this. And it's really the only way you have to limit the messages you get in a very large IoT situation, because you're registering only for the stuff that's of interest to you. Any questions on that, or is that clear as mud? I'll carry on. Okay, so that was basically IoT and MQTT. So what then have we been doing in OpenNMS to try and get into this space and do something with it? And so this, now, as I say, it's still a bit experimental. The code is all here. Basically, to build the code, Maven clean install, and you will get a, in the car package module, you'll get something called MQTT plugin.car, and you basically take that module, which is a car file is really just a packaged application that can run in a Carafe container. You just take that and you drop it into the OpenNMS deploy directory. So take your version of OpenNMS. This works against OpenNMS version 22. 22 is probably going to be the candidate for the next Meridian release as well, so it should work. Any 22 version of OpenNMS. Drop it into the deploy directory, and the plugin will start up. Now, the other thing you need is a configuration file, which is called MQTT interface config, and that will live in the etc directory. So in order to make this work, you just need to compile the thing, and then drop the car into the deploy directory, and then write your configuration and drop that into the etc directory. Write your configuration and put it in first before you deploy it. Top tip. Otherwise, it won't find it. Okay, so there's example config files, and I'll go through a bit more about what that means. And there is also a Docker Compose project up here as well, that basically if you run Docker Compose, it should bring up the whole thing: Cassandra, OpenNMS, the MQTT broker, and some example stuff. So it should make it easy for somebody to kind of get the thing going if you don't know where to start. And essentially what it does is it gives OpenNMS the ability to register with any MQTT broker and multiple MQTT brokers at the same time for the messages that OpenNMS wants to receive. And that's really what it does. And we can then take those messages and we can turn them into OpenNMS events, or we can turn them into OpenNMS data that will be stored in Cassandra. And then you can do all the normal processing you would do in OpenNMS with those messages after that. So, in summary, and I'll go into more detail, but I just wanted to summarize before I get lost in the weeds. It's a simple to install plugin. Basically, you drop it into deploy and you add your config file. It can connect and reconnect to multiple MQTT brokers. So by reconnect, if it disconnects for any reason, you can set timeouts so it'll try again and it'll reconnect. So it should maintain a connection to the broker even if the broker goes away and comes back. It has, sort of usual things, username and password for the broker, but you can also use TLS authentication as well. And that's very important if you were going to use Amazon IoT as your broker, because they require you to use certificates to identify yourself to the IoT platform. So you basically, when you're on your Amazon IoT dashboard, you can generate the certificate files and then you drop them into OpenNMS, and then that will work. It'll authenticate to Amazon. Again, instructions are provided. So it can then, so we've connected and we're now receiving the messages from MQTT. So what do we do with them? Well, you can either have already set up all the nodes that you're interested in OpenNMS, in which case the messages will be directed to the correct node according to the configuration. Or you can set up OpenNMS so that if it gets a message from a node that it wasn't expecting to get a message from, it will create that node. So that way you could have an environment where you're adding in new MQTT devices all the time, and OpenNMS will learn about them as those devices talk to OpenNMS. It'll automatically discover those devices. So you can either do it, you just like normal OpenNMS, you configure everything, or you can let OpenNMS learn about these devices. And when it learns about the device, you can include a certain amount of inventory information in the message that you're using to tell OpenNMS, I'm here. And the most important of those are the GIS coordinates. So if you want these devices to show up on the map in OpenNMS, if the device itself sends the GIS coordinates of where it is, then that will go into the inventory in OpenNMS. And that way you can see the device in its location. You can subscribe to filtered topics. So having connected to broker, then the broker itself may offer up many different devices. So you need to subscribe. So here is an example of subscribing to this. In this case, this is sort of typical of the sort of message. Depending on how you name your devices and how your platform provider works. In this case, we've got this string, and that's what you would register for. But supposing this was the ID of the device that you wanted to use, it's probably come from a MAC address of the device, but it doesn't matter. You'd basically put in a plus there, and you'd say, okay, give me all of these devices within that, and I don't care what its ID is, but I do care that it's sending me a JSON formatted message. So only send me JSON formatted messages from that device further on down. See, that's how this works from a filtering perspective. Now, that's the broker. So I'm saying when I register with my broker, I tell, sorry, is David Eustace?
Is that a feature in the plugin or is that a feature of MQTT?
Both.
So if it's just a string of bytes, how does it know it's a JSON?
Oh, sorry, it doesn't know it's a JSON message. that just happens to be the way this particular device identifies it's going to send you a JSON message. Okay, so you could have format XML, and you would actually direct that to a different processor in OpenNMS to handle the message. So you could have the same device sending different types of messages as well. Okay. So all this is doing is saying I've connected to my broker, so I can connect to multiple brokers. I've told my brokers these are the messages I want to receive. These are my filtered topics. So now I'm starting to receive this huge amount of messages that are coming in on these filtered topics.
The plus T in the second string means one particular type? Or?
The plus T is a mistake. Thank you for pointing it out. But hopefully you get the idea, and at least you're paying attention. Right, so having registered to receive, my messages, then I want to say, okay, is the message I'm going to receive going to be translated into an event in OpenNMS, or is it going to be translated into data in OpenNMS, or in fact, does this message contain both data and an event message? So you can do both. And to do that, then you'll set up filters within OpenNMS that say, okay, this particular string with data point in it, right, will go to my event handler, but any string that's got, with data point will go to my data handler, any string that's got events in it will go to the event handler. So you can register for all of your events, and then the events come in and you say, well, these types of events go to my event handler, and these types of events go to my data handler, or these events go to both. Okay, so that's the second level of subdivision. Now, as I said before, you can parse multiple payloads, and the MQTT standard does not specify what the payload should be. So I've come across examples of where there are zip compressed messages in the payload, where they're JSON messages, where they're XML messages, where they're just CSV messages, or indeed where they're protobuf messages. So there really isn't anything specified in the standard as to what those messages are. And of course the question is then, well, how do we handle the message when it arrives? How do we handle these different types of message when they come into OpenNMS? And so we've had to build this thing so it can parse different types of payload. So this is more under the hood to give you an idea of how it works, because this is really everything that's in the plugin. Okay, I'll just talk through it very briefly. So if you imagine you've got your brokers out here that aren't part of OpenNMS, and within OpenNMS you've defined an MQTT client that's going to talk to this broker, and another client that's going to talk to this broker. So that's the first thing you do. I'll talk about these things up there in a second. Those clients will receive the messages, and they'll be stuffed into a queue, which basically will grow as the messages come in. There's then a thread pool after that that's reading off those messages, and it's looking at the configuration based on the topic string associated with the message. And it's deciding, what am I going to do with this? Is this message going to be going to a JSON configuration, to an XML configuration, or potentially to a protobuf? Now, I haven't implemented the protobuf, I'll tell you that, but it's not that difficult to do, so it's mentioned here. Also, is the message compressed? Now, it actually turns out that in the case of Eclipse Cura, you can actually work out whether the message is compressed or not. So you've got the option of saying these messages will always be compressed, so I'll decompress them. Or you can say, well, this message is based on a few bytes at the beginning of the string, is probably compressed, and I'll decompress it. That particular option in Cura, they admit, is works most of the time, but occasionally messages will be misinterpreted. There we go. But they've included that anyway. But the point is that you decompress the message, then you handle it in some way, and then you send it to the OpenNMS persisters. And all of this stuff, in terms of persisting events and persisting data, that's all normal OpenNMS code. Nothing has changed here. The plugin basically stops at that point, and it just sends either data to be persisted to RRD and Cassandra, exactly the same as everything else in OpenNMS, or to be persisted as an event. And then all your event handling and correlation and everything can all go on just the way it would normally go on with anything. all the plugin is doing is getting us to that point where we've parsed the topic and the message and turned it into something we can save in OpenNMS and do something useful with. I will say that the one other thing that I've done as part of this is included a REST receiver. So you can also post MQTT messages to OpenNMS, and that's really for two purposes. One, for debugging, so you can actually do this without having to have a client and everything set up. You can post a message with a topic, a QoS, and a string of bytes, and it'll get parsed by everything else, so you can use it to actually test out whether it's working. But the other purpose of it was, and I'm not going to talk about this, but I'll let you know about it, did a little bit of work in the collections API, the data measurements API, to allow you to post formulas into OpenNMS and coefficients into OpenNMS, so that the normal measurements API, basically in your Grafana configuration, you have to tell it what the formula will be. Now you can actually have the formula stored as a property within OpenNMS, and the formula will be applied to the Grafana representation whenever it comes. Now, the reason for doing that was that in one of the use cases I'll talk about, which was an environmental use case, the sensors themselves were cheap sensors and basically not calibrated. So what you had to do was apply a calibration to the measurement. But we wanted to store the raw measurements in Cassandra, not calibrate them as they went in. So what we did was we said we'll store the raw measurements in Cassandra, but for that, for every device, we will also store a little formula and the coefficients, so that when you retrieve the data, you can apply that correction formula as you retrieve it. And you can change the correction formula. And that REST API, part of the purpose of that was to be able to post in those corrections. Now, how you calculate the corrections and all the rest is completely beyond the scope of this, but that was the purpose. And the reason was that we wanted to be able to render up the data reasonably accurately on Grafana for end users, even though the measurement devices were, cheap and nasty. And by doing some clever math on the measurements and comparing them with expensive devices that were also collecting the same data, we could more or less correlate them and calibrate them and use that measurement calibration mechanism. So that's the reason for it. But anyway, just mentioning that, I'm not going to talk about that anymore. So the basic structure of the configuration is you've got this file, MQTT interface config, and it's got a number of sections in it. And basically the first three things are saying, do I create a missing node? If the node doesn't exist, do I create it? Yes or no. If I create the node, do I create a dummy interface? Because you can create nodes without any interface on them. But there's an interesting bug in Grafana in that if a node doesn't have an interface on it, you can't search for it. So not so good. So sometimes you want to just create a dummy interface with an out-of-range IP address that just goes with that node, and that just identifies the node and allows Grafana to see it. And then do I create node asset data? Now, that really is targeted at creating the GIS coordinates in the asset database. Because if a node has an asset GIS coordinate, then it'll show up somewhere on the map where you want it to be. So the idea of this was that whenever the node announces itself, if it's got its GIS coordinates in its announcement, then when you create the node, you put them in the asset table and magic happens. Then you've got these message data parsers, of which you can have many, and event data parsers, of which you can have many. And then you have the clients. So the clients, as I said previously, basically connect to the broker and say what topics they want to receive on. But then having received the messages, we then either use any number of these data parsers or event parsers to actually turn the message into an event or into data. So that's the basic structure of the file. So this is the simple bit. This is setting up the connection. So basically, if I'm going to set up an MQTT client, I basically give it the URL of the client. I give it the client ID because you have to identify yourself to the broker. And then connection retie interval and connection wait. That's really just MQTT stuff to allow it to reconnect if the device goes away. And then the topic list. And these are the topics that you're going to send to the broker to to register for. So these can, as you can see there, have wildcards. So I'll have every MQTT event you can send to me, but I'll only have MQTT data from that one topic. So you can send filters into the broker so that you can say which ones we want to do. And a broker can have many, many different subscriptions associated with it. Then you have the username and the password, which is just authenticating to the broker. And you could also have certificate and key files, which are used to basically authenticate to the likes of Amazon, which you would have to do in that case. I think I've duplicated that, the URLs there twice. So anyway, that gives you an idea of how you connect to a broker. Then when you receive the data, so the message data parser basically has got, I'll just look at this, make sure I can see it without my glasses. Yeah, the important thing here is that for this particular message data parser, this is the topic that I'm going to match against. So all of this stuff here, which actually translates the data that I've received into something useful, will only apply to messages that come from that topic. So that's the filter. And you could have multiple topics that were related to those XML groups. I'll talk about the XML groups in a minute. So the idea being that when you set up the parser, you're saying it's going to be JSON, and it's going to be uncompressed, or it could be compressed, or whatever, as you can see up there. But you could also say it was XML, or potentially protobuf, or text. Text will be CSV. Okay? Any questions on that? So the messages come in to the client registers with the broker. The message comes in, and then the second level of filtering is done here that says only these messages from this topic will be handled by this configuration. So here's an example of a payload. So this is the sort of thing you would get from a device, right? So basically it's a JSON message, zones, and it actually has an array. So again, you don't necessarily just receive one data set. You might receive multiple data sets in a message. In this case, you've got an array of messages that have come in from that device. And each one of those messages would separately be turned into a data that's being put into OpenNMS. Okay? So you've got the zone that comes in, then you've got the name. Now, the name in this case is going to be matched against name here. Now, this is exactly the same, or well, it's very similar to Alejandro's XML data collector. Okay? It uses JXPath in exactly the same way. I reused a lot of his ideas, but I've extended it a bit to do some of this JSON stuff. But essentially, the key XPath here is going to give you the name of the node. So the name up here, global. The name of the node is going to be global. Okay? The timestamp XPath is picking up the timestamp. And you can put in a timestamp format. So in this case, it's just a simple integer, obviously. But you could also have any timestamp format you wanted. And you'd put the timestamp format in here, and it would parse that correctly. And then you've got all of the data that actually is going to be picked up from each of these values and pulled into the data set that's going to be sent into OpenNMS, into Cassandra, or into RRDs. Okay? But it will do it for the whole message. So it receives a message, and it may have multiple data sets with different timestamps against them. All of those will be parsed by this and turned into a separate message that goes into OpenNMS. Does that make sense? Okay. Now, in this example, the node ID was actually in the message. So in this case, I'm assuming, because you don't know these things, sometimes they put the node ID in the message, sometimes they put it in the topic path. So in this case, the node ID has been in the message, and we've pulled it in, and it's gone into the message that way. But in this case, we're actually getting the node ID from the topic path. So we've registered for the topic. We've put a wildcard in there, so that MAC address basically is going to be my ID address. And in this case, what I do is basically I put in this field, topic level 5, and it looks for the 5th field along. They're numbered from 1. So number 5 is the message that's actually going to be the actual message group here. Okay? So that means you can extract the node name both from the topic and also from the MQTT message itself. And I haven't shown examples with XML, but the XML parsing is exactly the same. And if you understand how Alejandro's JXPath stuff works, it works just as well with XML as it does with JSON. This does exactly the same thing. Okay? So that's how you basically extract the node ID from the topic path. And I think I've shown it elsewhere, but you can also extract the foreign ID as well from the topic path. So you can do both. So that way you can know an awful lot about your node when you're actually naming it and adding it to your database. Now, that was data event handling. And message event handling is very, very similar. All the parsing is the same, but there are some differences. So the first difference is, now here we can see that, all that stuff up at the top is exactly the same. The foreign source, as I actually said a minute ago, is actually going to be topic level 5 here. So in this case, I'm saying my foreign source is going to come from the topic field. I'm saying that that's going to be my topic I'm registering for. And then what I'm saying is, this is the root UEI for this message. So I'm going to, for every message that I receive from this device, this is going to be the UEI that's going to go into the event. Okay, so that'll be the root UEI. But obviously you don't want to just have one UEI for every message. So what you can then do is use XPath to extract these particular messages, right, which you'll then use to build up the string. So have I explained this right? Yeah, so the UEI suffix, right, is put into the XML object, and then you say it's devel UEI. So basically what I'm saying is that I'm going to use that part of the topic as part of the UEI. Or I could also use part of the message itself as part of the UEI. So I can change the UEI based on strings that I've received from my message. So I could have different events depending on the type of message I've received from the device. Okay? It may not make it awfully clear here, but there's lots of examples in the actual code itself. In the test cases, there are many configurations that would actually show you lots of permutations on this. But the point is, you can change the UEI based on the message. And then all of the data within the message, so all the parsing of the data, that all goes into the message as varbinds. So the data is all preserved, but it's all saved as varbinds in the message. So what you will get in your event, in this case, is an event with a custom UEI that's been modified by the message, and also a load of varbinds that have been taken from the message. And you can process that any way you want within OpenNMS. So all of that data has been turned into something that OpenNMS event handling can handle. So in summary, we can take a message, we can turn it into data that goes into Cassandra and shows up in Grafana and all of that stuff. And we can take the same message, parse it a different way, and put it into an event for OpenNMS. Okay. I've been told that I need to stop at some point to let somebody change the disk. Would this be a good time to stop? Oh, no? Okay, we'll keep going. So obviously I'm not taking up as much bandwidth as I thought. So that's event handling, right? So that's all I'm going to talk about, really, in terms of how it all works. And if it's blurred over for you, well, hopefully this will be a little bit more interesting, because these are the use cases that we've used to try this out and try and prove that the thing is useful. So the first one I want to talk about is a gentleman called Herb Garcia, who came along to our dev jam in Minneapolis. When he heard our dev jam was going on and he heard that I was doing MQTT stuff, he said, oh, that's really interesting, because I am working on a project. And he's basically he's a geologist by trade originally. And his interest was in mine tailings. So here we have a horrible lake full of poisonous, noxious stuff, which is called a mine tailing. And these mine tailings, they're made basically out of mounds of dirt that are just built around and then all that water and horrible stuff is in the middle. And every so often disaster happens because these mounds, somebody doesn't put their finger in the dike, and the whole thing just spills over everywhere. And there's been lots of cases of villages being destroyed and all the rest. So it's very important to be able to sense the state of these mine-tailing dams. And so Herb, bless him, has thought, here's a great opportunity. Why don't I get a load of sensors, position them strategically around the dam, and then I will use LoRaWAN, which is like a wireless protocol, very low power, to actually send messages from these devices to something. And oh, look, OpenNMS can receive these messages because they all send MQTT. So we could, in theory, create a capability to monitor this dam using OpenNMS with MQTT messages coming from these sensors. And he's working on this project now, and he's trying to get the message out there about what he's doing. And I've been working quite closely with him to sort of, every time he comes up with a problem, I say, oh, well, maybe fix that and get it working. And so we're using this as a really good use case. And we're hoping that he will be able to offer a service to mine operators, of which there are millions all around the world, where he could monitor these little remote probes and tell if there's a problem. And he would use OpenNMS to do his data collection for that. So that's one case. Now the other case, which is closer to home for me, was Solent AirWatch sadly no longer exists as a project because the chief guy seems to have left. There's other work going on in the city which may recover this, but basically the plan was to create lots of little sensors using Raspberry Pis, which would be low-quality air sensors, but would be, as I said previously, calibrated against high-quality air sensors. And they would send their data using MQTT to OpenNMS, and then the calibration would be applied whenever the data is rendered up. And the idea was that we would have a community of 50 to 100 people around the city who'd have these little sensors in their home or just stuck on the wall outside their home, sending data so we get an idea of the pollution across the city. Because as you can see here, pollution is a very big problem in the city because these big ships show up, QE2 and whatever, and they don't turn off their engines, and they're like having 500 lorries drive up and down your city for the duration that they're in town. So it's a big problem. So that was the intention. And so I've been working on this project for some time. A lot of the work I did in OpenNMS was around this, but at this point in time, Solent AirWatch itself is in a little bit of a hiatus. But nonetheless, we've learned something from that. The final example I wanted to show you is stuff. So myself and Ronnie went to the RIPE NCC hackathon in Dublin, and Patrick Tweet from eNet came along, and so we thought, here's an interesting little project we could work on. Why don't we see if Patrick can get his data from Amazon CloudWatch out of Amazon and into OpenNMS? And so what he did was he set up a configuration in CloudWatch that basically says, these are the measurements I want. Normally, it would just send it into the iOS, the Amazon messaging bus, simple messaging. But then he basically set up the Amazon IoT broker to listen to the simple messaging and then to send it up as a topic. So basically, you could get OpenNMS to register on the Amazon IoT topic and receive all of these performance measurements. So it just was a proof of concept to show that it would be possible just using even the existing IoT MQTT client to actually get a whole stack of performance data out of Amazon CloudWatch into OpenNMS and then do whatever you needed to do with it after that in terms of visualizations or Grafana and everything else. So another really good use case. And of course, the other thing that proves is we can connect to Amazon IoT. So there will be probably a lot of situations where people will just say, I'll use Amazon IoT because they handle the connectivity, they're available all over the world, and they'll do all that magic. But all I will need to do is to set up a topic to send my messages to, and a topic which OpenNMS will receive from. And the cost of doing that will be minuscule compared to the cost of using Amazon's own services. Excuse me. So, opportunities there. The final thing I wanted to talk about briefly, can you get me some water, please? Sorry. Was that I've got a master's student at Solent Uni who's been looking at these devices. Now, Sniffy, the thing which was working with Solent AirWatch, was basically using Python scripts It was a very simple cron job. They just ran the script, and the script would go off to the sensor, which is a laser particle sensor. Excuse me a second. I'm soaking wet now as well. That's good. Cooled me down. So that worked, but it wasn't really what we wanted for long term. So what Ben's been looking at is saying, well, can we re-implement that using all of these other technologies? So he wrote a simple Java program to do the same thing as Sniffy, and then he's looked at using Node-RED to do the same thing. And we've also been looking at Eclipse Core and OpenHub, although we haven't been very successful at getting these working yet. So he's basically come up with a Node-RED, which generates a beautiful little UI for the device itself on the Raspberry Pi, and sort of just makes it much more professional if somebody wants to install the thing. So anyway, that's work that we were doing really around this to actually have a remote collector that could send data to OpenNMS, and it's just work in progress. So I'm winding down now, and obviously my disk hasn't run out, which is good. Basically, I think as a result of this and other work that's been going on in OpenNMS, we have a very credible IoT story, which you just need to get out there. Regardless of anything else, we've got this data collection capability to send data into Cassandra and Elasticsearch, which is very powerful in its own right. We've got the drift stuff and the streaming protocols around that, and somebody will talk about that later in the week. The work that I've done isn't using the Drift API particularly, and there's a number of reasons for that. The point is that you've got options, okay? We've got the minions, which again could be out there collecting data. And then we've got this MQTT plugin, which can work with multiple remote MQTT brokers. So lots of ways of getting streaming data into OpenNMS, rendering it and storing it, and that makes it a very credible story. The prototype MQTT program, it appears to work well. Of course, I haven't really tried it at scale yet, but that's for somebody to do. And there's a Docker Compose project for it. So if you want to get the whole thing up and running, if you look at the project, you can just run Docker Compose and it'll run up OpenNMS, Cassandra, the broker, and hopefully you're 90% there and getting it going without having to do a load of work. So I'd really say, thank you for listening. Please spread the word. If you've got an IoT project or you know somebody who's doing IoT, you might want to just point them at what we've done. Try the plugin yourself if you want. You can always email me if you want help. And please give us feedback as to what to do next. So with that, I shall finish. Thank you for listening. Have you got any questions? Mr. Eustace.
I'm glad to see that we've not introduced any more complexity.
Well, of course.
That whole message format thing, where I was like, if you can just send any message in with the string of bytes, is it like a pluggable infrastructure for like, here's the configuration for these type of IoT devices to parse this type of message? Is that?
Essentially it is. It's not, it's configuration obviously, and I haven't done anything around having a multiple files, so it's all in one file at the moment. But yes, the idea is that you set up the topics associated with the type of parsing you want to do, and you can have multiple different parsing for different.
So you can register a parser with the topic.
Yes, exactly what you do. And you can have multiple parsers against the same topic to pull out different types of data. Sorry, Jess.
I thought it would be really interesting to see that implemented in like a live situation where somebody like me, who doesn't necessarily code or anything, but I could see, like you were showing with the air pollution, like have even a live graph of what does it look like from day to day. So just as somebody who's more marketing focused, like something that's interactive and interesting to the general public, obviously the AirWatch is super interesting.
Thank you for that question, Jessica. I'll just repeat it for the camera. The question was there any sort of live example of this up and available for folk to look at to see the data coming in? And the answer is yes, there was up until about 3 months ago, because we were doing stuff with these sensors around Southampton. I'm trying to revive the project in some way or other. But regardless of that, I will get an OpenNMS instance up with some data on it. I did some work with Grafana as well, so that you could actually display geographically displaced nodes on Grafana. There's a Grafana map plugin, and I kind of worked out a way in which you could use OpenNMS data to drive that. So again, it was a really nice sort of demo of here's a map of the city, here are the sensors, they're green or they're red, depending on the pollution, and then you could see a little pollution graph below that. It's all standard Grafana stuff with a little bit of work on one of the Grafana plugins. So I did have that, but unfortunately, I don't have it today. Thank you. Anything else? Dustin?
At first, I want to point you to the German project Luftdaten.info, which is the German-wide air pollution sensor system on community base, which is basically all the implementation of the technologies you described, which works with a couple of hundreds of sensors in Germany right now. And the second thing is more a question. Have you already looked into all that standards which currently pop up on top of MQTT to do some kind of meta description of the MQTT topics itself? So like there's, I think one of them is called HOMI, which uses MQTT topics to describe which sensors are available on each device, and then maybe having some kind of auto detection of these sensors.
Yeah, so the two questions, if that didn't come out on the tape, were Dustin pointed out that there is a project in Germany that already does this data monitoring. They've got their own software. I was aware of at least one. I think there's several actually in Germany, and there's also one in Newcastle. So in a sense, there are bits of software out there that already do this. So one of the questions obviously is, why bother? Well, the answer to that is that these bits of software have only got a single purpose, as far as I can tell. I mean, they can expand to do other IoT stuff. They can't do anything else. Whereas OpenNMS does a raft of stuff already, and adding MQTT onto OpenNMS makes all of that available to anybody who wants to do it. So I would love to encourage folk that we're starting with a new sort of IoT problem, and this is obviously a marketing issue, to have a look at OpenNMS and what we've done, rather than necessarily looking at some of these other projects, which also quite often are written, in scripting languages or whatever. Not saying that one is, I don't know, but don't necessarily scale the same way as OpenNMS would. So we're just another game, in the park, but I think that we have some benefits in terms of the maturity and longevity of OpenNMS, rather than these projects that have really just, many of them, grown up as research projects. Dustin also asked about, have I looked at metadata for discovering devices using topics? The short answer is no. It would be interesting to do that. So that's maybe another master's project for somebody to look at. Maybe you can tell me more about that later. Any others? Yeah. Sorry.
So the logo for Open Home Automation Bus.
OpenHub?
OpenHub, yeah, which is what I use to control my house. And it's running on a Pi with sensors and everything, so I could show it. So the integration should be pretty easy.
I would have thought so.
With MQTT to integrate Open Home Automation Bus to an OpenNMS
should
instance
be
running on that Docker, so a question of minutes.
Well, you can give it a go and let us know how you get on. But I would be interested to see how you get on, because I haven't really played with OpenHub. But if OpenHub can throw stuff up as MQTT, then hey, why don't we try it and see what we get? David had another question, I think.
It reminds me of at DevJam when you remember when Will did his presentation for OpenNMS, and he was talking about how he was using OpenNMS as infrastructure for event.
Yes.
Management and using Drools, and you asked him this question was, why didn't you just implement with Drools like out of the box? And he said, well, it was more than that. It was all the infrastructure that comes with OpenNMS, was the event configuration to persistence to GUI, right? So it was like, I can see where your point is that a lot of these frameworks have infrastructure for message handling, but they don't really have that cradle to grave platform. Not only that, for scale, right? So it makes a lot of sense.
Yeah, I think it's true. I mean, it's almost like, I like analogy between, it's like the analogy between comparing Joomla to WordPress. Joomla, you get it out of the box, and you got all these bits on the floor, and it takes you forever to work out how to get it to work. I'm told, I've not done it, but I'm told WordPress, you can get a WordPress site running straight away, and then you can modify it. And so this stuff of OpenNMS may not do everything that you want, but you'll get it running quickly. Whereas some of these other platforms, particularly some of the bigger ones, you got to set up so much stuff before you get it to do anything, and you know that makes it difficult. Sorry, Uwe.
You also said something about 500 lorries running up and down the street. What's a lorry?
Truck. A lorry is a truck, David. It's a very small one that you play with. I'll get you one. Okay, look, thanks very much indeed. Talk to me afterwards. Appreciate it. Thanks.